Okay, fifth grade, we're going to look at, this is day 7, and what we've got here is adding and subtracting fractions in word problems. So we're probably going to have to be looking at making some common denominators. So the good news is the more you do, you'll start to actually know what the common denominators are. So it's just going to get easier. All right, lesson day 7. Write the missing numbers to show equivalent fractions for some common numbers used as benchmarks. So we've seen that benchmark, that's just something you know. Like, you know what 1/2 a pizza looks like. You know what 1/4 of a pizza. Oh, let me put these in order here. Hold on. You know what 1/4 of a pizza looks like. You know what 1/2 a pizza. You know if something's about 3/4, and you certainly know a whole pizza when you see it. Okay, so here we go. So we have 1/4. So notice if you want to write an equivalent fraction to 1/4, you take that pizza. Again, this is all you're doing. And there's 1/4. And now if we double the number of slices, whoops, didn't get the black. If we double the number of slices, of course, now we have 8 slices, 2 out of 8. 2/8 is the same as 1/4. More slices, but they are smaller. If we triple the number of slices, take that black line off here. Triple the number of slices. Should be a little more even than that. Triple the number of slices. We have 12 slices in all. Instead of one big piece, we now have 3 much smaller pieces. But the same amount of total pizza. Same amount of total pizza. And that is what we're doing. Okay, let's do a half pizza down here. We'll do a half. On a half, we got that one. So if you have a pizza with 8 slices, half of the number of slices would be 4. That's a half. If your pizza has 10 slices, what would half the slices be? 5/5, 5/10. Okay, now we have 3/4. Let's look at 3/4. So let's make a pizza. Put it into 4 parts. There is 3/4. Now, if we double the number of slices, we have 8 parts, just like right here. But instead of 3 big slices, we have 6 smaller slices. Ta-da! Okay, now we will triple the number of slices. If we triple the number of slices, we have to cut it across twice. We now have 12 slices in all. Instead of 3 big slices, we now have 3, 6, 9. Okay? And again, I didn't show this earlier, but doubling, that's times 2, right? There's times 2. Times 2. Tripling is times 3. So 4 times 3 and 3 times 3. Easy cheesy. Okay, now the next one is kind of interesting because they're saying we have 2 whole pizzas. Okay, so, and remember, wholes and parts, that's all. It says 2. Fine, we can do that. Let's make 2 whole pizzas. Not a problem whatsoever. Okay. Next one says we want each pizza to have 2 parts. We can do that. Oh, let me shade that in. So we have 2 whole pizzas. So this is our whole pizza. Our whole pizza there. Okay, now each pizza has 2 parts. Remember, that's what the 2 means. It means that each whole pizza Okay? 2 parts or 2 halves. So how many halves altogether? 1, 2, 3, 4. We have 4. That's why we have more than 1 whole. Okay? It only takes 2 parts to make a whole, and we've got 4 of those. Let's look at the next one. We want each pizza to have 4 parts. Not a problem. That pizza now has 4 parts. That pizza now has 4 parts, just like it says down here. So we now have 4/4 here. That's 1 whole. And another 4/4, another whole. We have 8/4. It's another way of saying we have two whole pizzas, right? Okay, let's come down here. The Graff family made 2 pizzas. They ate 1 1/8 pizza before watching a movie and a half pizza more after the movie, which is a reasonable estimate for the amount of pizza that's left. Okay. All right, so we got to go. Let's write this down. So a little bit at a time here. They made 2 pizzas, so we can actually just make 2 pizzas. Okay. They ate 1 1/2. So let's put that down here. They have 2 pizzas. They ate 1 1/2 pizza. I'm sorry, 1 1/8. Now this is asking for a reasonable estimate. So 1 1/8 is just a little bit more than 1. So we're going to put -1. So they ate about 1 pizza, and then they before the movie, and then they ate another half pizza afterwards. So we're going to subtract 1/2. Now that might look weird. So you could have just said, well, 2 minus 1, because we can only subtract 1 at a time. But remember, order of operations. That's what we're doing. We're gonna here's the first pizza. They ate about 1. They ate about 1 pizza. Then they ate about 1/2. Okay. 2 minus 1 is 1. 1. Right. Let's do this part first. Our order of operations. 1 minus a half is a half. They have about a half left. Okay. Now, what they're saying here is it less than a half, more than a half, less than 1 1/4? Well, first of all, these are not good estimates because we know it's about a half. So we got to ask ourselves, do we have less than a half, more than a half? All right. Look at this part up here. We took 1 1/8 and we said that's about equal to 1. So we actually went from 1 1/8 with our estimate. We rounded down to 1, didn't we? It's close to 1, but remember, it is a little more than 1. So we round it down. So we actually have a little more than 1 right here, a little more than 1 pizza minus. So if we have a little more than 1 right here, we should have a little more than 1/2 here. Hopefully that makes sense. So it's a little more than 1/2, okay? Tammy chose A as the correct answer. How did she get that answer? Tammy chose A. We have less than 1/2. How'd she get the answer? Well, maybe what Tammy did was maybe she just didn't really think about the fact that they rounded down. So I would say Tammy rounded 1 1/8 to 1, but she forgot that she rounded down. So if you have something like that, that'd be fine. You could spend more time trying to explain it. But as long as you got the basic, you understand. When you round, it's not going to be exact, and when you estimate, it's not exact. One part of estimating is to know, well, is your answer going to be a little above or below the actual? In our case, we're saying we're a little below the actual. Okay, she actually has a little more than 1/2. And that's just, helpful to round, helpful to when you're doing your estimate. Okay? Lexi bought 1 2/5 pounds of green grapes, so 1 2/5 pounds, and 2 3/10 pounds of red grapes. Grapes are $2.99 a pound. Did she spend more or did she spend less than $12? Okay. She bought 1 2/5 and 2 3/10. Grapes are $2.99 a pound. Did she spend more or less? Okay. Oh, then $12 on the grapes. Okay. So probably the easiest thing to do here is to find out, well, how many grapes altogether? So 1 2/5. And again, think about this. This is just like going to the store. She just went to the store to buy some grapes. So what would you do at the store? Well, you'd put all your grapes together and they're $2.99 a pound. So 1 2/5 plus 2 3/10. Okay. And you'd say, well, I can't add those. Those aren't common denominators. But you're probably starting to get the idea that, you know what? If I count by fives, if I skip count by 5, I'm going to get 10. So I can change that. I'm going to change that bad boy right up. So let's do that. I'll do it over here. 2/5. And I'm going to cut that pizza so it has 10 parts. So I'm going to double the number, right? And I got to double the number of slices I have. So 2/5 is equivalent to 4/10. More slices, but they're smaller. Now let's rewrite it. Instead of 1 2/5, 1 4/10 plus 2 3/10 equals 3 7/10. 3 7/10. I gotta pause for a second here. Hold on. Okay, so now let me fix this 7/10 part there. So now we have 3 7/10. Now, here's the question says, well, did she spend more or less than $12? So since they're not asking for an exact answer, we can use a little estimation. Okay? So what we can say here is, I'll come over here. 3 7/10. 3 7/10 is about, okay? Now remember, if you got 10 parts in your pizza, if you have half of that would be 5. So this is more than half. So if this was a pizza, we're only 3 slices away from a whole. So this is about 4 pounds. Okay, it's about 4 pounds. But remember, we're rounding up. So our actual, if we were to find out exactly how much she spent, it's going to be less than this, right? Because we're kind of pretending like we have 4 pounds of grapes. We really only have 3 7/10, so a little less, right? But we're pretending like we have more. So we have to kind of keep that in mind. So we know when we finish our estimate, that means it'll be a little high. We also know that they're $2.99 a pound. So $2.99 a pound, that's an awkward number to work with. And we just want to know about, did she spend more or less than $12? That's about $3, right? Again, we're rounding up. So it's really less than $3. So what we've done with our estimate is we've said, okay, we rounded up the actual number of pounds to 4, and we rounded the price up for each pound a little bit also to 3. So our estimate is going to be a little on the high side. It's going to be a little above what she actually spends, because she actually has fewer pounds of grapes and the price is actually a little lower. But boy, is that easy to work with. Now look at that. So you have 4 pounds of grapes, 4 times $3 a pound. Look at that. We can quickly come up with an estimate. It says she spent about $12. Since we rounded everything up, our estimate's on the high side, she's actually going to spend less than $12. So that's how we answer our question. So Lexi spent less. You can say, I know this. You can, if you have room, you can always write that. I know this because, and just, again, when you're writing a mathematical explanation, you just write what you did. Well, what did we do? I know this because I rounded the pounds of grapes up. The amount, I'll put. I rounded the amount. Oops. That should be of. I rounded the amount of grapes up to, we'll say from 3 7/10 to $4. I'm going to do this in a different color. Oops, thought I was going to do, oh golly, I'm having trouble with the colors here. Hold on. I also, oh darn, I also rounded the price up from $2.99 to $3 per pound. So when we're writing a math explanation, what do we do? First thing we do, answer the question. We answer the question. Lexi spent less than $12. It says explain. I know this because I rounded the amount of grapes up. I also rounded the price up. Okay? Nice. Okay, here, let's take a look at our next one here. And I think I'm going to pause right there. Okay, so we're back now. We're going to finish up. We've done a great job with doing these, adding and subtracting these fractions and using some estimation. Here we go. On Monday, Marco practiced piano. He practiced for 7/10 of an hour. Tuesday, he practiced 1 5/6 hours. He's supposed to practice 1 1/4 hours each day. Okay, so Monday, he practiced, and actually we can kind of come over here and do that. Monday, he did 7/10. Tuesday, he did 1 5/6. He's supposed to practice, okay? He's supposed to practice 1 1/4 hours each day. So we're supposed to use this information to write a question. Write a question that involves adding or subtracting fractions. So you could do several things. One could be a lot of questions. We could say, how much did he practice all together, right? Monday and Tuesday. We could say, how much, now he's supposed to practice 1 1/4 hours each day. We could say, how much less did he practice on Monday than he was supposed to, okay? And we could also do like this one, 1 5/6, that's almost 2 hours. We could say, how much more did he practice than he's supposed to on Tuesday? So there's a variety of questions that we could ask here. There's a variety of things we could ask. Excuse me. So why don't we just do how much did he practice in all? Okay, how much did he practice all together? On Monday and Tuesday. Okay, so let's, now this next part here says, look at the question you wrote in your in problem 4, excuse me, sorry, show how to estimate the answer. Oh, and then find the actual. We talked about that before, so we're going to estimate, and then we're going to find the actual. So let's come down here, and let's do Monday. You practice 7/10. Tuesday, we said it was 1 5/6. Okay, so let's estimate. You know, let's round these numbers and estimate. So if I put an E, if I put estimate, I'll just do EST, period. So this is my estimate. So here's what I'm going to say. 7/10 of an hour. Okay, now if that's half an hour, if that hour is broken into 10 parts, if he does 5 parts or 5/10, that'd be a half. So this is more than a half. This is more than a half. And it's 3 slices away from a whole. So that's pretty close to a whole. So I could say, you know, he practiced about, well, is it closer to a half than a whole? Maybe we'll say about a half, 1/2 hour. And I'm picking that because I'm kind of rounding this one down to 5/10. It's closer to 5/10 than it is to 10/10. So we're going to round that one down. And this one is 1 5/6. So if the hour is divided into 6 parts, 1 more part, 1 more 6, and I'd have 2 hours. So I'm going to round it up to 2 hours. So I estimate that together he practiced about 2.5 hours altogether. Well, what's the actual? So let's do the actual. So let's find out how close that you know, see how good our estimate was. So let's actually do 7/10 plus 1 5/6. Well, I don't have the same number of parts in my whole. I don't have the same number of parts. So I've got to find a common denominator. So I'm going to do a little skip counting and find out what that's going to be. They call that listing the multiples. And so I'm looking for the least common multiple. They call it the LCM. Because that's what you do when you skip count. You just list a multiple. So I'll do 10s, 10, 20. I usually just do the first 3 to see how close we can get. And 6 would be 6, 12. I don't have any matches. 18. No matches. 24. And I can see where this match is going to go. I have to go all the way to 30. You know, you could kind of see that was going to happen because 10, you know it's 10, 20, 30. You know the multiples, okay? And then 6, I'm looking for something that's going to end in a 0. It's going to be 6 times 5. So, what this is, start to practice some new terminology here, is this is the least common multiple, which becomes my new denominator. And actually, it's called my least common denominator, my LCD. And the smallest denominator, the first one that they have that's in common, it's going to be the best. It'll be less work for me. All right, so I got to rewrite my fractions. Let's rewrite them, right? Let's write those fractions. 7/10. I'm changing that into a fraction that has 30 parts, right? So I have to triple the number of parts, triple the number of parts. Of course, they're just getting smaller. 7/10 becomes 21/30. That's supposed to be a plus sign. Oops, boy, I'm really getting tired here. It's a little late to be doing this in the day. Okay, here we go. Now let's do 5/6. Okay, so 5/6. And that has to be into 30 parts. I have to multiply that times 5. So that's 25. And remember, this is 1 5/6, so it's 1 25/30. I'm going to have to erase, oh, maybe not, maybe not. Maybe I can squeeze, I'll use a different color and I'll squeeze it in there. Let's use a purple, I guess. Okay, this equals, add up the wholes, so I only have one whole, 21 and 25, so we can kind of figure that's 46/30. Okay, now 46/30ths. I can make more wholes out of that, right? So what you're really saying is, how many groups of 30 go into this 46? Well, I can get one group of 30, and of course 30/30ths is one whole, and then I have 16/30ths. Agreed? So this is equal to, I'll put it right below there, this is equal to, I already have one whole, right? And I have another whole. So this is the same. 30/30ths is the same as one whole. So I can just put a big 1 over the top of that. So I've got that one, and then I've got this one over here. So that's 2 wholes. Now 16/30ths. We can start to talk about that we have to simplify fractions. Okay, so if we're going to simplify, it just means, I'm going to write this fraction with, the numbers that are just easier, smaller numbers. 16/30ths, it's just awkward. So let's divide. All we do is just divide something that goes into both the numerator and the denominator. Like when we make, this common denominator, we multiply by the same thing. So now we're just gonna, and multiplying makes these numbers larger, right? Well, just dividing them makes it smaller. So we'll just keep it simple. So let's do divide by 2. That's an easy one to start with. So 16 divided by 2 is 8. 30 divided by 2, 15. And I can't simplify it anymore. So my final answer is 2 and 8/15. So how close is that? That's our actual. How close was our estimate? Well, if I have 15 parts. So if I have 15 parts, and let's say that's a pizza with 15 slices, think about that. If you had to divide that up, you would give 7 to one friend and 7 to another. You'd have 1 piece left. You'd have to split that piece in half. So each person would get 7.5. So I have 8/15. So I have a little over a half. So I mean a very little over. So look how close our estimate was. And that's why estimates are just really good. We could have just said right then and there, he practiced about 2.5 hours. Okay? All right, did a great job. I'm gonna wind that one up, that day 7 up. We'll do day 8 here. We'll keep going. For anybody that's missed the classes, they can come and kind of review and go back through.